Okay, here's level 2. This is problem 6. Oops, grab the pen. Minimize this. Grab the pen. Okay. So 6 is, here's why this is level 2. There's an extra step. So 0.01, 0.0436 cubic meters to cubic centimeters. What makes this a little bit tougher is these threes. And so to do this problem, you first pretend that the threes aren't there. So this is just one letter. It's not a cm or a pm or a mm. This is 10 to the 0. That means meter. One letter means you're on the meter step. This is 10 to the negative 2. How far is it on a number line? From negative 2 to 0, it's actually 2. So one of these is 100 times bigger than the other. 10 to the 0 is bigger than 10 to the negative 2. So 1 meter is 100 centimeters. But interesting, notice these are to the first power and these are to the third power. And so when that happens, this is a volume problem. Because in science, linear units is what we measure length or distance in, and square units is what we measure area in, and cubic units is what we measure volume in. So because, first of all, you pretend that they're not there and you just do like we did in level 1. But now, because they're there, you have to cube them. And 1 cubed is still 1, but a meter times a meter times a meter is a cubic meter. And 10 squared to the third is 10 to the sixth. This is the power of the power rule. This actually means 10 squared times 10 squared times 10 squared 3 times, and 2 plus 2 plus 2 is 6. So if you have a power inside the parentheses and a power outside the parentheses, you can just multiply them. And then a centimeter cubed is a cubic centimeter. And so again, just like last worksheet, you write down the problem just like it was given. And then if there's no fraction there, you put it over 1. And then because cubic meter is on the top, this half of the conversion factor has to go downstairs or it won't cancel. And so then and then top and bottoms cancel. And 0.436 times 10 to the 6th is, my worksheet says 4.36 times 10 to the 5th cubic centimeters. The calculator might say 436,000, which is an equivalent representation, because we know that if we take this decimal place and slide it 5 times, we get the same answer. And either one of these two answers I would take. And then coming over here, let's try 7. And what makes 7 kind of tricky is it's the first time we've had units in the top and the bottom. So 9.06 kilometers per hour. And we want to convert this to centimeters per minute, and just do the numerator or the top first, and do the denominator or the bottom second. So kilo means 10 to the positive 3, and centa means 10 to the negative 2. How far is it on a number line from negative 2 to positive 3? Well, it's actually 2 here and 3 here for a grand total of 5. So one of these is 5 powers of 10, bigger than the other. The 1 goes with the bigger number, so 1 kilometer is 10 to the 5th centimeters, and that takes care of the numerator. And then if you go back to the definitions I gave you earlier, 1 hour is the same thing as 60 minutes. And so now we're ready to solve the problem. So what goes in the first set of parentheses is 9.06 kilometers per, and I'm going to put per 1 hour. This 1 is implied. So if you're going down the freeway 9.06 kilometers per hour, it implies that you will go exactly 9.06 kilometers in 1 hour. Now this one has 2 conversion factors. So kilometer is on the top, so the 1 kilometer goes down. The 10 to the 5th centimeters goes up. This cancels this. If I stop the problem right now, I'd be in centimeters per hour, but I'm trying to get to centimeters per minute. Now this is crazy. It's the first time we've happened. Hour is on the bottom. So this time 1 hour has to go on the top. 60 minutes goes down. Hour cancels hour. And what's going to get put in your calculator is 9.06 times 10 to the fifth. Okay, don't put ones in there. Divided by 1 times 60. And if you do that, I actually have an online calculator here. So if we do 9.06, oops, I just did 9.05, 9.06 times 10 caret 5 divided by 60, and push enter, the calculator will say 5,100, which is the answer on the sheet. So I'll go back. Sorry, not 5,000, 15,100. What's the only unit upstairs that hasn't canceled? Centimeters. What's the only unit downstairs that hasn't canceled? Minute. Okay, next problem in level 2 is 8. This one really bugs the kids, and it kind of cracks me up every year, so I just want to talk about it slow. I want you to convert 0.307 milligrams per cubic centimeter to grams per cubic centimeter, and this is the thing that I think is funny, that it bothers them, which is why I actually put it on the worksheet. There's no law that says you have to change the top and the bottom. If you look at this problem carefully, we want to change the numerator from milligrams to grams, but we don't want to change the bottom. That's okay. You don't have to change them both. So let's do the top. Milli is 10 to the negative 3. This is one letter. There's no prefix. This is 10 to the 0. How far is it on a number line from negative 3 to 0? It's 3 powers of 10. What's bigger, 10 to the negative 3 or 10 to the 0? 10 to the 0. So grams goes with the 1. So 1 gram is 1,000 milligrams. We don't need a conversion factor for the bottom because we're not changing the bottom. So what goes in the first set of the parentheses? The original problem. So 307 milligrams per 1 cubic centimeter. And then because milligrams is on the top, 10 to the third milligrams is on the bottom. 1 gram is on the top. This cancels this. 0.307 times 1 divided by 1, parentheses 1 times 10 to the third. Anyways, if you put this in the calculator, you get 3.07 times 10 to the negative 4 grams is on the top, and cubic centimeters is still on the bottom because we didn't change it. You could also, an equivalent representation would be 123,307 because, let's go purple, 1, 2, 3, 4. If the original number is small, if the negative exponents are smaller than 1 and positive exponents are bigger than 1. So I would take either of these answers. All right, next problem in level 2, 9, is 267 square centimeters, square, to square kilometers. This one's interesting because of these squares. This is an area problem, so remember I said just ignore them at first. What does centa mean? 10 to the negative 2, just like a cent is 100th of a dollar, a centimeter is 100th of a meter, and kilo is 10 to the third. So how far is it on a number line from negative 2 to positive 3? It's 5. And then what's a bigger number? 10 to the third or 10 to the negative 2? 10 to the third. So kilometers goes with 1, and centimeters goes with 10 to the fifth. Now you got to realize though, these 2's are here. So as soon as you get that, now you have to square it. So if both of the units is squared, you square the conversion factor. If both of the units are cubed, you cube the conversion factor. And if nothing squared or cubed, it means to the first power, and you don't have to do that. So then I come over here. 1 squared is still 1. A kilometer squared is a square kilometer. 10 to the fifth squared is 10 to the 10th. Power to the power rule. These get multiplied, square centimeters. And so 267 squared centimeters over 1 goes in the first set of parentheses. And then because square centimeters is on the bottom, 10 to the 10th square centimeters goes down, 1 square kilometer goes up. And so 267 times 1 divided by 10 to the 10th, you get 2.67 times 10 to the negative 8 square kilometers. Let me just show you that quickly on a calculator. So if you want to go 267, oops, got to clear my last answer. 267 times 1 divided by parentheses 1 times 10 caret 10. Boom. And there's your, oh, interesting. They left it in scientific notation. But if you went 1, 2, 3, 4, 5, 6, 7, 8, you would get the same answer. I would take either of those answers because they're equivalent representations. And then last one in level 2, 10, we want to convert. This one's crazy because of the sig figs. 0.3 millimeters per second. And we want to convert this to kilometers per hour. And again, nothing squared or cubed in this problem, but you have 2. So we have to do, okay, there's 2 letters here. So the first M means 10 to the negative 3, and the K means 10 to the positive 3. And how far is it on a number line from negative 3 to positive 3? Always go to 0 in the middle. It's actually 6. So one of these is 1,000,000 times bigger than the other. 10 to the third is bigger. The bigger thing always goes with the 1. So 1 kilometer is 1,000,000 millimeters. The units, there's no squareds or cubes, so you're done. And then 1 hour is 3,600 seconds. Because there's 60 minutes in an hour, and there's 60 seconds in a minute, so 60 times 60. And then what goes in the first set of parentheses is the original problem, so 0.03 millimeters per 1 second. Means this is a velocity, so every second something is going 3/100ths of a millimeter. Now millimeter is on the top, so millimeter has to go on the bottom. 10 to the 6th millimeters goes down, 1 kilometer goes up. This cancels this. If I stop the problem right now, my unit would be kilometers per second, but I want kilometers per hour. In the original problem, second is on the bottom, so the 3,600 seconds per 1 hour has to go on the top. This cancels this. Switching colors here. Nothing canceled with this, and nothing canceled with that. And so the unit is kilometers per hour. And if you put 0.03 times 1 times 3,600, you really don't have to do the ones, divided by parentheses 1 times 10 caret 6 times 1. The calculator will say, actually I don't remember what it says, but it doesn't say this because this number only has 1 sig fig. And again, when you do a problem in chemistry, you get the numerical answer, and then by how many digits you keep, it tells you how good your measuring instrument was. So hitting clear, if I type in 0.03 times 10 to the 6th divided by 3,600, calculator will say, oh no, I did something wrong. That's not the problem. I could go here. What is it? It's, oh, I had those flipped. Sorry. It's hard for me to go back and forth. All right, so let's hit clear. So we're going to go 0.03 times 3,600 divided by 10 caret 6. And you get this. So 0.00108. Yeah, that's what I remember. So you get 0.000108. But this number has 1 sig fig. This is a definition. This is a definition. And this number has 3, and we only get to keep 1. So either this or, sorry, that's 0.0001, or 1 times 10 to the negative 4 if you want to put it in scientific notation. 1, 2, 3, 4. All right, that's it for level 2.